Smart Kids: How AI is Transforming Education delves into the profound impact of artificial intelligence on modern educational systems. The book begins by tracing the evolution of AI technologies and their initial applications across various sectors, setting the stage for a focused discussion on education. It highlights how AI tools are revolutionizing learning experiences by personalizing education and preparing students for future tech-driven economies. The core of the book examines detailed case studies from schools worldwide that have integrated AI systems effectively. These examples not only showcase the benefits but also tackle the challenges and ethical dilemmas posed by AI in educational settings. Through interviews with leading experts in education and artificial intelligence, the narrative provides deeper insights into adapting AI for diverse learning environments, from primary schools to universities, and discusses its role in democratizing education. Additionally, Smart Kids forecasts emerging trends and potential future advancements in AI that could further transform educational practices. The book encourages educators, policymakers, parents, and technology enthusiasts to proactively engage with AI tools to enhance educational outcomes and prepare students for a digitally literate world. By embracing these innovations, the book argues that stakeholders can significantly improve how education is delivered while equipping young minds to thrive in a digital future. 1. The evolution of artificial intelligence. The journey of artificial intelligence, AI, technologies has been transformative, evolving through various phases from theoretical underpinnings to practical applications impacting numerous sectors, including education. The inception of AI can be traced back to the mid-20th century when the concept of thinking machines transitioned from fiction to scientific inquiry. This period marked by the Dartmouth Conference in 1956, where John McCarthy coined the term artificial intelligence, set the stage for decades of innovation and research. Initial explorations into AI were dominated by symbolic approaches, where the focus was on programming computers to mimic human problem-solving and reasoning processes using rules and logic. This era saw the development of early AI programs like ELIZA and SHRDLU, which interacted with users in a constrained language and performed tasks in simplified worlds, respectively. However, these systems lacked true understanding and were limited by the amount of knowledge that could be explicitly encoded by programmers. The limitations of early AI led to what is known as the AI winter, a period during which funding and interest in AI research waned significantly due to unmet expectations. Despite these setbacks, dedicated researchers continued their work, leading to significant breakthroughs such as the development of machine learning algorithms in the 1980s. These algorithms allowed computers to learn from data, improving their performance over time without being explicitly programmed for each task. The resurgence of interest in AI was fueled further by advancements in computational power and data availability. The introduction of deep learning architectures like neural networks, particularly since 2010, has dramatically enhanced the capabilities of AI systems. These technologies now underpin many modern AI applications across various industries, including education. In educational settings specifically, AI's historical evolution is reflected in its current applications designed to personalize learning experiences. From intelligent tutoring systems that adapt to individual student needs to data-driven insights that help educators tailor their teaching strategies, AI's impact on education is profound and growing. As we continue into an era where technology becomes even more intertwined with daily life, understanding this historical context not only enriches our appreciation of current innovations, but also informs future developments in educational technology. 1.2 Initial applications in various sectors. The early applications of artificial intelligence, AI, spanned across various sectors, demonstrating the versatility and potential of AI technologies to revolutionize traditional processes. These initial forays into applying AI set the groundwork for its pervasive use today, showcasing both successes and areas for improvement. In healthcare, AI's introduction was marked by its integration into diagnostic procedures. Systems capable of analyzing complex medical data allowed for quicker and more accurate diagnoses compared to traditional methods. For instance, AI algorithms were employed to analyze X-ray images and identify patterns indicative of specific diseases such as tuberculosis or cancer at their nascent stages. This not only improved patient outcomes but also significantly reduced the workload on healthcare professionals. The finance sector also saw transformative changes with the adoption of AI. Early applications included algorithmic trading, where systems were designed to execute trades at a speed and frequency that is impossible for human traders. Moreover, AI was utilized in fraud detection systems which monitor unusual patterns in transaction data that might indicate fraudulent activities, thereby safeguarding consumer interests and enhancing security measures within financial institutions. In manufacturing, AI initially contributed through robotic automation that transformed production lines. These robots were programmed to perform repetitive tasks with high precision and at unprecedented speeds, leading to increased productivity and efficiency while reducing human error. Additionally, predictive maintenance technology emerged. Here, AI-driven systems predict equipment failures before they occur by analyzing operational data, thus minimizing downtime and extending machinery life. Furthermore, the retail sector leveraged AI to enhance customer experiences through personalized recommendations based on shopping behaviors analyzed from vast datasets. This not only increased customer satisfaction but also boosted sales by targeting users with products they are more likely to purchase. Each of these sectors benefited distinctly from the infusion of artificial intelligence during its formative years. The successes observed laid a robust foundation for further research and development in AI technologies, while highlighting critical challenges such as ethical considerations and the need for robust data privacy measures. As we delve deeper into each application, it becomes evident how integral these early implementations were in setting the stage for today's advanced uses of artificial intelligence across industries. 1.3 Emergence of AI in education. The integration of artificial intelligence, AI, into the educational sector marks a significant evolution in teaching and learning methodologies. AI's emergence in education is transforming traditional classrooms, enabling personalized learning experiences, and enhancing administrative operations within educational institutions. One of the most notable applications of AI in education is the development of personalized learning environments. AI systems analyze individual student performance and adapt instructional materials to suit each learner's unique needs and pace. For example, platforms like Khan Academy use data from student interactions to tailor exercises, videos, and assessments that are optimally challenging for each student. This approach not only helps in addressing the diverse learning styles and speeds found in a typical classroom, but also enhances student engagement and retention rates. Furthermore, AI has been instrumental in automating administrative tasks that traditionally consume considerable time for educators and administrators. AI-powered tools are now capable of handling scheduling, grading, admissions processes, and even responding to student inquiries via chatbots. This automation allows educators to devote more time to teaching and less on bureaucratic tasks. AI's role extends beyond just personalization and administration. It also offers significant advancements in accessibility. Tools such as speech-to-text technologies or smart content creation help make learning materials accessible to students with disabilities like visual or hearing impairments. For instance, Microsoft's Immersive Reader tool uses AI to enhance reading comprehension among learners by adjusting text spacing, providing syllable division, and reading text aloud. The predictive capabilities of AI are being used to improve educational outcomes by identifying at-risk students early on. Systems equipped with machine learning algorithms can detect patterns based on performance data that indicate a student might be facing difficulties. Early intervention can then be implemented through additional support or tailored learning strategies aimed at mitigating dropout rates. In conclusion, the emergence of AI in education is facilitating a shift towards more inclusive, efficient, and personalized learning environments. As these technologies continue to evolve, their potential to transform every aspect of education becomes increasingly evident, promising significant benefits for students, teachers, and educational administrators alike. References: Khan Academy, ND, Personalized Learning, retrieved from https://www.khanacademy.org. Microsoft Education, ND, Immersive Reader, retrieved from https://www.microsoft.com/and-us/education/products/immersive-reader. Zawacki Richter, O. Marine, V. I. Bond, M. and Gouverneur, F. 2019. Systematic review of research on artificial intelligence applications in higher education. Where are the educators? International Journal of Educational Technology in Higher Education, 16, 1, 39. 2. AI integration in global educational systems. In the exploration of AI's integration into educational systems, primary and secondary schools present unique case studies that illustrate both the challenges and successes of these technologies in younger educational settings. These examples not only demonstrate practical applications of AI, but also offer insights into its impacts on teaching methodologies and student engagement. One notable example is a primary school in Sweden that has implemented an AI-driven learning platform which adapts to each student's individual learning pace. This tool uses data analytics to provide personalized tasks for students, enhancing their understanding by focusing on areas where they struggle the most. Teachers report that this system not only improves academic performance but also boosts students' confidence as they see tangible progress in their learning journeys. Similarly, a secondary school in Japan has integrated AI to assist in language classes. The AI software analyzes student speech patterns and provides immediate feedback, helping students to improve their pronunciation and fluency more effectively than traditional language labs or audio-based practice tools. This technology also allows teachers to track progress over time and tailor lessons to address specific linguistic weaknesses. However, these advancements are not without their challenges. For instance, a high school in Brazil faced significant hurdles integrating AI tools due to inadequate digital infrastructure and training for staff. Initially, there was resistance from teachers who felt overwhelmed by the new technology. Through professional development programs and gradual implementation strategies, the school managed to overcome these obstacles, ultimately enhancing interactive learning experiences across various subjects. The ethical considerations of using AI in schools are also critical. Questions about data privacy, surveillance, and the potential for bias in AI algorithms are at the forefront of discussions within educational communities. Schools must navigate these issues carefully to maintain trust among students, parents, and educators while harnessing the benefits of technology. These case studies underscore the transformative potential of AI in education when implemented thoughtfully with adequate support structures. They highlight a future where education is highly personalized, interactive, and supportive through intelligent technologies. 2.2 AI implementation in higher education. The integration of artificial intelligence, AI, in higher education is reshaping the academic landscape, offering both unprecedented opportunities and significant challenges. Universities around the world are adopting AI to enhance personalized learning, streamline administrative operations, and foster research advancements. One of the primary applications of AI in higher education is through adaptive learning platforms. These systems utilize algorithms to analyze a student's performance and tailor educational content accordingly, thereby addressing individual strengths and weaknesses. For instance, Georgia Tech introduced an AI teaching assistant named Jill Watson, which helps manage large student queries in online courses efficiently. Moreover, AI is instrumental in automating administrative tasks which often consume considerable time and resources. By implementing AI-driven systems for enrollment, scheduling, and student services, institutions can reduce overhead costs and allocate more resources towards academic enhancement. The University of Murcia in Spain uses an AI system to optimize class schedules based on students' course preferences and faculty availability. Research has also benefited significantly from AI technologies. Advanced data analysis tools powered by AI are enabling researchers to process vast amounts of data at unprecedented speeds, leading to quicker insights and discoveries. For example, MIT's Computer Science and Artificial Intelligence Laboratory, CSAIL, employs machine learning techniques to analyze data from scientific experiments faster than ever before. However, the deployment of AI in higher education is not devoid of challenges. Issues related to data privacy, ethical concerns regarding surveillance on campus, and biases inherent in algorithmic decisions pose significant hurdles. Moreover, there is a growing need for curriculum updates that include data literacy to prepare students adequately for an increasingly automated world. In conclusion, While the implementation of AI in higher education promises enhanced efficiency and personalization of learning experiences, it requires careful consideration of ethical implications and strategic planning to ensure it serves all stakeholders effectively. As this technology continues to evolve, educational institutions must remain vigilant about integrating these tools responsibly into their operational frameworks. 2.3 Addressing challenges and ethical considerations. The integration of AI into global educational systems, while promising, presents a complex array of challenges and ethical considerations that must be addressed to harness its full potential responsibly. This section explores these issues in depth, highlighting the primary concerns and proposing strategies for mitigation. One significant challenge is the protection of data privacy. Educational institutions collect vast amounts of personal information from students, which AI systems analyze to enhance learning experiences and operational efficiency. However, this raises concerns about data breaches and unauthorized access. For instance, sensitive student data could be exploited if cybersecurity measures are not robust enough. To counteract this risk, schools must implement stringent data protection policies and ensure compliance with global standards such as GDPR in Europe or FERPA in the United States. Another critical issue is the potential for bias in AI algorithms. These biases can perpetuate inequalities in educational outcomes if not carefully managed. For example, if an AI system is trained on historical data that reflects past prejudices, it may continue to favor certain groups over others unless explicitly designed to counteract these biases. Institutions need to adopt transparent methods for developing and auditing their AI tools, involving diverse teams in the design process to minimize biases from the outset. Ethical considerations also extend to surveillance concerns. The use of AI-powered monitoring tools on campus can lead to a Big Brother environment, infringing on students' rights to privacy and potentially stifling academic freedom. Universities must strike a balance between leveraging technology for security purposes and maintaining an open academic atmosphere conducive to learning. Furthermore, there is an urgent need for curricular updates that include ethics training related to AI usage. As future professionals who will interact with AI technologies regardless of their field of study, students must understand both the capabilities and limitations of these systems, including ethical implications. In conclusion, while AI offers substantial benefits for enhancing educational practices globally, addressing these challenges through careful planning, stakeholder engagement, and adherence to ethical standards is crucial for its successful integration into educational frameworks. References: General Data Protection Regulation, GDPR, ND, retrieved from https://gdpr-info, EU Family Educational Rights and Privacy Act, FERPA, ND, retrieved from https://www.gov/policy/gen/guid/fpco/fairpa/index, HTML Zoe, J. and Schiebinger, L. 2018. AI can be sexist and racist. It's time to make it fair. Nature, 559, 7714, 324-326, doi. 10.1038/D4, 1586-018-05707-8 O'Neill, C. 2016. Weapons of Math Destruction: How Big Data Increases Inequality and Threatens Democracy. Broadway Books. 3. Enhancing Learning Through AI Tools. The integration of artificial intelligence, AI, in education has ushered in a new era of personalized learning, fundamentally transforming how educational content is delivered and consumed. AI's capability to analyze vast amounts of data allows for the tailoring of learning experiences to individual student needs, preferences, and learning speeds. This personalization is pivotal in fostering an environment where all students can thrive. AI-driven systems facilitate the creation of personalized learning paths by assessing each student's performance on various tasks and identifying specific areas of strength and weakness. For instance, if a student excels in mathematics but struggles with reading comprehension, AI tools can adapt the curriculum to provide more intensive reading exercises while continuing to challenge their mathematical abilities. This adaptive learning approach not only keeps students engaged, but also ensures that they are neither underchallenged nor overwhelmed. Beyond adapting to academic capabilities, AI technologies consider cognitive and emotional factors that influence learning. Emotional AI systems, sometimes referred to as effective computing systems, can detect subtle cues such as facial expressions or changes in tone during interactive lessons. These insights enable the system to adjust the difficulty level or even suggest breaks when students show signs of frustration or fatigue, thereby supporting a more humane and responsive learning environment. The benefits of personalized education extend into accessibility, particularly for students with disabilities or those from non-traditional learning backgrounds. AI tools can offer customized resources like audiobooks for visually impaired learners or gamified content for students who benefit from interactive elements due to attention deficit disorders. Such inclusivity not only democratizes education but also levels the playing field so that every student has the opportunity to succeed regardless of their personal circumstances. Moreover, personalization through AI fosters a deeper connection between students and their educational journey by allowing them to have a say in how they learn best. This empowerment leads to increased motivation and engagement, which are critical components of effective learning. As we continue to explore and refine these technologies, it becomes increasingly clear that AI has the potential not just to improve educational outcomes but also to revolutionize the way we think about teaching and learning altogether. 3.2 Tools for enhancing engagement and retention. The advent of AI in education has not only personalized learning but also introduced sophisticated tools aimed at boosting student engagement and retention. These tools leverage AI's ability to analyze learning patterns, optimize content delivery, and foster interactive environments that keep students motivated over long periods. One significant advancement is the use of intelligent tutoring systems, ITS. These systems simulate one-on-one interaction between students and tutors. The AI in these systems assesses a student's current knowledge base and tailors instructions to fill knowledge gaps effectively. By providing immediate feedback and personal attention, ITS can mimic the benefits of private tutoring, making learning more engaging for students. Another tool integral to enhancing engagement is gamification. AI-driven gamification incorporates elements such as points, badges, and leaderboards into the educational process. This approach not only makes learning fun but also addictive in a positive way by tapping into the psychological aspects of competition and achievement. For instance, an AI system can create dynamic challenges tailored to the student's progress in subjects like math or science, adapting difficulty in real time based on performance. AI also plays a crucial role in creating collaborative platforms that encourage peer interaction and collective problem solving. These platforms use AI to match students with peers who have similar learning styles or academic goals, thereby facilitating more effective group work and discussion forums. Such interactions are vital for developing critical social skills and deepening understanding through peer-to-peer explanation. To address varying attention spans among learners, AI-powered attention tracking tools help customize the pace of lessons. These tools analyze eye movements or mouse clicks during digital lessons to gauge interest levels and modify lesson delivery accordingly. For example, if a student's attention wanes, the AI might introduce interactive elements or take a break before continuing with the lesson. In conclusion, AI tools are revolutionizing how engagement and retention are approached in educational settings by introducing adaptive learning technologies that cater to individual needs while maintaining a collective educational experience that is both inclusive and effective. 3.3 Evaluating the impact on learning outcomes. The integration of artificial intelligence, AI, in educational tools has significantly transformed teaching methodologies and learning experiences. However, to truly measure the effectiveness of these AI-driven interventions, it is crucial to evaluate their impact on learning outcomes comprehensively. This evaluation not only helps in assessing whether the AI tools are meeting their intended educational objectives, but also provides insights into how they can be improved for better efficacy. Evaluation methods vary widely but generally involve both quantitative and qualitative approaches. Quantitatively, standardized tests and assessments can be administered before and after the implementation of AI tools to measure improvements in knowledge acquisition and retention rates. For example, if an intelligent tutoring system, ITS, is introduced in a mathematics course, students' test scores before and after its introduction can be compared to assess any significant improvement in understanding mathematical concepts. Qualitatively, surveys and interviews can be conducted with students and educators to gather feedback on the usability and perceived effectiveness of AI tools. These insights are invaluable as they reveal subjective experiences that might not be captured through test scores alone. For instance, students might report increased motivation or a deeper understanding of complex topics due to interactive AI features like gamification or personalized learning paths. Another critical aspect of evaluating learning outcomes involves analyzing data collected by AI systems during their interaction with students. This data often includes metrics such as engagement levels, time spent on tasks, and frequency of tool usage. Advanced analytics can then be applied to this data to identify patterns or correlations between the use of specific AI features and academic performance improvements. Furthermore, longitudinal studies that track learners over extended periods provide a more comprehensive view of how sustained use of AI tools affects educational trajectories. Such studies help determine whether short-term gains translate into long-term retention and success beyond the classroom environment. In conclusion, while AI offers promising enhancements in education through personalized learning experiences and increased engagement, rigorous evaluation is essential to ensure these technologies contribute positively to learning outcomes. By employing a combination of quantitative assessments, qualitative feedback, detailed analytics, and longitudinal research, educators can optimize AI implementations to achieve desired educational goals effectively. References: Kulik, J. A. 2003. Effects of using instructional technology in elementary and secondary schools. What controlled evaluation studies say. SRI International. Baker, R. S. and Smith, L. 2019. Educational Data Mining and Learning Analytics in Programming, Literature Review and Case Studies. Journal of Educational Technology and Society. DeMello, S. Duckworth, A. and Dieterle, E. 2017. Advanced, Analytic, Automated AAA Measurement of Engagement During Learning. Educational Psychologist. Lynch, G. and Pinkwart, N. 2020. A survey on the use of AI-driven personalization in massive open online courses. MOOCs, Computers and Education. Zawacki Richter, O. Marine V. I. Bond, M. and Gouverneur, F. 2019. Systematic Review of Research on Artificial Intelligence Applications in Higher Education. Where are the educators? International Journal of Educational Technology in Higher Education. For expert insights on AI in education in the exploration of AI's role in education, interviews with seasoned educators and technologists provide invaluable insights into the practical applications and theoretical implications of these technologies in learning environments. These discussions reveal both the enthusiasm for potential benefits and the caution due to ethical considerations. One primary insight from these interviews is the significant impact of AI on personalized learning. Educators report that AI tools have enabled a more tailored educational experience that adapts to individual students' learning paces and styles. For instance, adaptive learning platforms use algorithms to analyze students' performance and modify content delivery accordingly, ensuring that each student can learn at their optimal pace. Technologists, on the other hand, emphasize the advancements in AI that make these personalized experiences possible. They discuss the development of sophisticated models that can predict student outcomes and identify areas where interventions are needed most. Moreover, they explore how natural language processing, NLP, has been pivotal in developing tools that can understand and respond to students' queries in real time, simulating a human-like tutoring experience. However, both groups also address challenges associated with implementing AI in educational settings. Educators express concerns about data privacy and the ethical use of student information. There is an ongoing debate about how much data is appropriate to collect and how it should be used to benefit student learning without compromising privacy. Another challenge highlighted involves equity in access to AI technologies. Both educators and technologists recognize that there is a digital divide. Not all schools have the resources to implement advanced AI systems. This disparity raises concerns about widening gaps in educational quality between different socioeconomic groups. The interviews also touch on future trends, where experts predict increased integration of AI into everyday classroom activities. They foresee AI becoming a common tool not just for personalized learning but also for administrative tasks like grading and providing feedback, thereby freeing up teachers to focus more on classroom engagement and less on routine tasks. In conclusion, while AI presents exciting opportunities for enhancing education, it also brings forth complex challenges that need careful consideration. The insights from these interviews underscore the importance of balancing innovation with ethical standards to truly harness AI's potential in education. For point 2, tailoring AI for diverse learning environments, the integration of artificial intelligence, AI, into diverse learning environments necessitates a nuanced approach that considers the unique characteristics and needs of different educational settings. This section explores how AI can be tailored to enhance learning experiences across various contexts, ensuring inclusivity and effectiveness in its deployment. One critical aspect of tailoring AI in education is the adaptation to different cultural and socio-economic backgrounds. AI systems must be designed to understand and respect cultural nuances that influence how students learn and interact with technology. For instance, language models used in AI tutors should be capable of handling multiple dialects and languages, reflecting the linguistic diversity of learners. This customization not only improves user engagement but also ensures that AI-driven solutions are equitable and accessible to all students, regardless of their background. Furthermore, the physical infrastructure of schools plays a significant role in shaping AI implementation strategies. In regions with limited access to reliable internet or modern devices, AI solutions need to operate effectively under low-tech conditions. Developers might need to create lightweight AI applications that require minimal bandwidth or can run offline on basic devices. Such considerations help bridge the digital divide, allowing students from less privileged schools to benefit from advanced educational technologies. Another dimension is the varying educational levels and abilities among students within the same classroom. Personalized learning powered by AI can address this challenge by providing adaptive learning paths tailored to individual student needs. For example, an AI system could analyze a student's previous answers and learning speed to adjust the difficulty level of subsequent content or suggest additional resources tailored to their specific learning gaps. In conclusion, tailoring AI for diverse learning environments involves understanding and addressing a wide range of factors including cultural differences, infrastructural limitations, individual learning capabilities, and accessibility needs. By focusing on these areas, educators and technologists can ensure that AI tools deliver personalized, inclusive education solutions that cater effectively to all students. Inclusive education also extends to students with disabilities, where AI can offer significant support. Voice recognition and response systems can assist visually impaired students, while predictive text and speech-to-text functionalities can aid those with dyslexia or other learning difficulties. By incorporating these features, AI tools make learning more accessible for students with special needs, promoting an inclusive environment where every student has the opportunity to excel. For point 3, best practices for integrating AI into curricula. Integrating artificial intelligence, AI, into educational curricula is not merely about incorporating new technology. It's about reshaping the educational landscape to foster a generation of students equipped with the skills necessary for a digital future. This section delves into the best practices that educators and curriculum developers should consider to effectively integrate AI into learning environments. The first step in integrating AI into curricula is ensuring that there is a solid foundational understanding of what AI is and its potential impacts. Educators should be provided with professional development opportunities focused on the basics of AI, its ethical implications, and its applications in education. This foundational knowledge is crucial for teachers to feel confident and competent in using AI tools within their teaching practices. Secondly, it's essential to align AI integration with educational goals and standards. AI should not be used just for the sake of technology, but should serve as a tool to enhance student learning outcomes. Curriculum developers need to work closely with AI experts to design learning activities that utilize AI in meaningful ways, such as personalized learning experiences where AI tailors instructional materials according to individual student needs and learning paces. Another best practice involves selecting appropriate AI tools that are reliable and safe for classroom use. It's important for schools to conduct thorough evaluations of AI technologies before implementation to ensure they are secure, privacy compliant, and effective. Engaging with reputable vendors who understand the educational context can help in choosing the right tools that add value to student learning rather than complicating or hindering it. Incorporating interdisciplinary projects can also enhance the integration of AI into curricula by showing students how AI intersects with various fields such as mathematics, science, humanities, and arts. For example, an interdisciplinary project might involve students using machine learning algorithms to analyze historical data patterns or create art pieces inspired by computational design. To address equity issues associated with access to technology, schools must ensure that all students have equal access to AI resources. This may involve investing in infrastructure that supports widespread technology use or developing offline solutions that allow students without home internet access to participate fully. Finally, continuous assessment and feedback mechanisms should be established to monitor the effectiveness of AI integration within educational programs. Regularly gathering input from both students and educators about their experiences with AI tools can provide insights into how well these technologies meet educational objectives and where improvements might be needed. In conclusion, integrating AI into curricula requires thoughtful planning, ongoing support for educators, careful selection of tools, interdisciplinary approaches, equitable access to technology, and robust evaluation processes. By adhering to these best practices, educational institutions can maximize the benefits of artificial intelligence in fostering enriched learning environments that prepare students for future challenges. References: International Society for Technology in Education, ISTE. Artificial Intelligence in Education: Promises and Implications for Teaching and Learning. ISTE, 2021. Donnelly, K. J. and Wiltshire, T. Integrating AI into K-12 Education, A Guide for School Leaders. Future of Life Institute, 2022. Zawacki Richter, O. and Latcham, C. Exploring the Educational Potential of Artificial Intelligence. Educational Technology Research and Development, 2019. Goldberg, M. E. Ethical Considerations in Integrating Artificial Intelligence into Schools. EdTech Magazine, 2020. 5. Democratization and Accessibility of Education via AI. The integration of artificial intelligence, AI, in education presents a transformative opportunity to bridge the socio-economic divides that have long plagued educational systems worldwide. By leveraging AI, educators and policymakers can provide customized learning experiences that cater to the diverse needs of students from varying backgrounds, thus democratizing access to quality education. One significant aspect of AI in overcoming these barriers is its ability to offer personalized learning paths. AI systems can analyze individual student performance and learning styles to tailor educational content accordingly. This personalized approach ensures that students who may need more time or different methods to understand concepts can receive the support they need, irrespective of their economic background. Moreover, AI-driven platforms can extend educational opportunities to remote or underserved regions where traditional resources are scarce. Through technologies such as mobile learning apps and online courses equipped with AI tutors, students in these areas can access high-quality education without the need for physical infrastructure. This not only helps in leveling the playing field, but also in reducing urban-rural educational disparities. Another pivotal role of AI is in scaling cost-effective solutions for education. AI technologies can automate administrative tasks like grading and scheduling, reducing the burden on educators and allowing them to focus more on teaching and less on paperwork. This efficiency gain reduces operational costs, making it feasible for institutions to redirect funds towards improving educational content or reaching out to economically disadvantaged students. Furthermore, AI facilitates real-time data collection and analysis, enabling educators and policymakers to identify gaps in the system quickly and implement targeted interventions. For instance, if data shows that students from a particular socioeconomic background are consistently underperforming, specific programs can be designed using AI insights to address these challenges effectively. In conclusion, as Smart Kids highlights through various global case studies and expert interviews. Embracing AI tools in education not only enhances learning outcomes, but also plays a crucial role in overcoming socioeconomic barriers. It empowers all students with the skills necessary for thriving in a tech-driven future, while ensuring equitable access to educational resources. 5.2 Role of AI in special needs education. The integration of artificial intelligence, AI, into special needs education marks a significant advancement in tailoring learning experiences to meet the unique requirements of students with disabilities. AI technologies offer innovative tools that can transform educational practices, making learning more accessible and engaging for students with special needs. One of the primary benefits of AI in this field is its ability to create personalized learning environments. AI systems can analyze the abilities and learning patterns of individual students, allowing for the customization of lesson plans and materials according to each student's specific needs. For instance, AI-powered applications can modify text size, background color, or even provide alternative text formats like audio or simplified language versions depending on the student's profile. Furthermore, AI facilitates the development of assistive technologies that support communication for nonverbal students or those with severe speech impairments. Technologies such as voice recognition software and predictive text functionalities enable these students to communicate their thoughts and participate actively in classroom activities. This not only enhances their learning experience but also boosts their confidence and social skills. Another critical application of AI in special needs education is through behavioral analysis tools. These tools monitor and analyze student behavior patterns to identify potential disruptions or difficulties that might affect their learning process. Educators can use this data to adjust teaching strategies or interventions specifically designed to help the student remain focused and engaged. AI also plays a crucial role in continuous assessment and feedback mechanisms which are vital for special education. Adaptive testing systems powered by AI can adjust the difficulty level of questions based on the student's responses, providing a more accurate measure of their understanding without causing frustration or demotivation. In conclusion, as we continue to explore and implement AI-driven solutions in special needs education, it becomes increasingly clear that these technologies hold great promise in creating more inclusive educational environments. They not only cater to diverse learning needs but also empower students with disabilities by providing them with tools that support their educational journey effectively. 5.3 Making quality education universally accessible. The quest to make quality education universally accessible is a pivotal challenge in the modern era, particularly as disparities in educational resources continue to widen globally. Artificial intelligence, AI, stands at the forefront of addressing this issue by democratizing access to high-quality learning experiences irrespective of geographical, economic, or social constraints. AI-driven platforms can provide scalable solutions that adapt to the needs of diverse learner populations. For instance, AI can facilitate the creation of personalized learning paths that cater to individual strengths and weaknesses, effectively leveling the playing field for students from varied backgrounds. This personalization extends beyond mere academic content delivery. It includes adaptive assessments, real-time feedback mechanisms, and predictive analytics to identify students at risk of falling behind. Moreover, AI technologies enable the development of virtual tutors and mentors that are accessible 24/7, thereby removing barriers related to the availability of human instructors. These AI systems can guide students through complex problem-solving processes or language learning, offering explanations, supplementary materials, and support in multiple languages. This not only enhances learning outcomes but also fosters a more inclusive educational environment where language and time constraints are minimized. In regions with limited educational infrastructure, mobile-based AI applications can make a significant impact. These apps require minimal data usage and can operate on low-cost devices, making them suitable for use in remote areas where traditional educational resources are scarce. By integrating AI with mobile technology, educators can reach out to underserved communities, providing children and adults alike with opportunities for lifelong learning and professional development. In conclusion, as we harness AI's potential to transform educational landscapes around the world, it becomes increasingly possible to envision a future where quality education is not a privilege but a universally accessible right. The continuous advancement of AI technologies promises not only to bridge educational gaps, but also to propel global societies towards more equitable knowledge economies. Furthermore, AI's role in gathering and analyzing vast amounts of educational data cannot be understated. Through sophisticated data analysis techniques, AI helps policymakers and educators understand patterns and trends in student engagement and performance across various demographics. This insight is crucial for designing interventions that promote equity in education by targeting resources where they are most needed. References: Baker, R. S. and Smith, L. 2019. Educational Data Mining and Learning Analytics in Programming, Literature Review and Case Studies. Journal of Educational Technology. Carnoy, M. 2021. The Promise of Education and Technology in Developing Countries. International Journal of Educational Development. Hallstein, K. McLaren, B. M. and 11 V. 2018. Intelligent Tutors as Teachers' Aides. Exploring Teacher Needs for Real-Time Analytics in Blended Classrooms. Learning Technologies. Luckin, R. Holmes, W. Griffiths, M. and Forcier, L.B. 2016. Intelligence Unleashed. An Argument for AI in Education. Pearson Education. Selwyn, N. and Bulfin, S. 2016. Digital Technology and the Contemporary University. Degrees of Digitization. Routledge. 6 Future Trends and Advancements in Educational AI: The Rapid Evolution of Artificial Intelligence, AI, in the educational sector hints at a future where learning is highly personalized, accessible, and intertwined with technology. As we look ahead, several innovations stand poised to further revolutionize how education is imparted and received. This exploration delves into potential advancements that could shape the next generation of educational tools and methodologies. One significant area of innovation is the development of predictive AI systems that can forecast individual student performance and suggest tailored learning pathways. These systems use data analytics to assess students' past performance, learning styles, and engagement levels to predict future outcomes and recommend resources that match their learning pace and style. This proactive approach not only enhances learning efficiency but also helps in early identification of students who might need additional support. Another promising advancement is the integration of AI with immersive technologies like virtual reality, VR, and augmented reality, AR. These technologies can simulate complex environments for practical learning experiences without the physical constraints. For instance, medical students could perform virtual surgeries or explore human anatomy in 3 dimensions, providing them with hands-on experience in a controlled setting. Similarly, history students might virtually visit ancient civilizations, enhancing engagement and understanding through experiential learning. AI-driven natural language processing tools are also expected to become more sophisticated, enabling more intuitive interactions between students and educational content. Future AI systems could potentially understand student queries better and provide explanations in a conversational manner, making digital learning assistants much more effective. These advanced systems could adapt to the student's proficiency level, offering explanations that are just right for their current understanding. Furthermore, as AI continues to advance, its role in democratizing education will likely expand by breaking geographical barriers. AI-powered platforms could offer high-quality education resources globally, ensuring that students from all socioeconomic backgrounds have access to the same quality of education. This not only fosters equality but also nurtures a globally competitive workforce equipped with diverse skills. In conclusion, while these innovations promise exciting enhancements in educational practices, they also necessitate careful consideration regarding ethical standards and privacy concerns. As such technologies take root in educational settings worldwide, stakeholders must ensure they are implemented responsibly to truly benefit future generations. 6.2 Preparing for a tech-driven educational future. The landscape of education is undergoing a profound transformation, driven by rapid technological advancements. As we prepare for a future where education is increasingly mediated by technology, it becomes crucial to equip educators, students, and institutions with the necessary tools and mindsets to thrive in this new environment. One of the primary steps in preparing for this tech-driven future is enhancing digital literacy across all levels of education. This involves not only familiarizing students with basic software, but also teaching them about cybersecurity, digital ethics, and the use of advanced technologies such as AI and blockchain. By integrating these topics into curricula, educational institutions can cultivate a technologically adept workforce ready to tackle future challenges. Another critical aspect is the development of adaptive learning technologies that use AI to tailor educational content to the needs of individual learners. These systems assess a student's performance in real time and adjust the difficulty level or suggest additional resources based on their progress. This personalized approach helps maximize learning efficiency and keep students engaged, catering to diverse learning styles and paces. Investment in robust IT infrastructure is also essential. Schools and universities need high-speed internet access, cloud storage solutions, and advanced computing devices to handle sophisticated educational software. Furthermore, training programs for teachers on how to effectively integrate technology into their teaching practices are vital. Professional development should include hands-on workshops on using educational platforms and troubleshooting common technical issues. To address equity issues associated with technology access, policies must ensure that disadvantaged communities receive adequate resources. This could involve government subsidies for tech equipment in low-income schools or partnerships between educational institutions and tech companies to provide discounted services. In conclusion, preparing for a tech-driven educational future requires comprehensive planning and collaboration among various stakeholders, including educators, policymakers, technology providers, and the community at large. By embracing these changes proactively, we can ensure that our educational systems are resilient, inclusive, and equipped to deliver quality education in an increasingly digital world. 6.3 Encouraging proactive engagement with emerging technologies in the evolving landscape of educational technology. Proactive engagement with emerging technologies is not just beneficial but essential for shaping future-ready learners and educators. This section explores strategies to foster an environment where students and teachers are not only receptive to but also actively involved in experimenting with and adopting new technological tools. The first step towards encouraging proactive engagement is creating awareness about the potential impacts and benefits of emerging technologies. Educational institutions should organize workshops, seminars, and talks that highlight real-world applications of technologies like artificial intelligence, AI, virtual reality, VR, augmented reality, AR, and Internet of Things, IoT. These events can demystify tech concepts, making them more accessible to educators and students alike. Another crucial aspect is integrating these technologies into the curriculum in a way that encourages hands-on learning. For instance, coding drones or creating VR content can be included in project-based learning modules. This not only enhances technical skills but also fosters creativity, problem-solving, and critical thinking, skills imperative in navigating a tech-driven world. To support this integration, schools must invest in up-to-date technology infrastructure. This includes not only hardware like computers and VR headsets, but also software platforms that allow for the exploration of AI algorithms or blockchain technology. Access to these resources ensures that all students have equal opportunities to engage with cutting-edge tools, thereby addressing potential equity gaps in tech education. Moreover, partnerships between educational institutions and tech companies can provide valuable resources such as expert mentorship, access to advanced technology tools, and real-world project experiences. These collaborations can help bridge the gap between theoretical knowledge and practical application, making learning more relevant to current industry standards. Finally, fostering a culture that celebrates innovation is key. Schools should encourage experimentation by setting up innovation labs where students can work on their projects under the guidance of teachers or industry professionals. Competitions or hackathons centered around emerging technologies can also motivate students by rewarding creativity and innovation. In conclusion, encouraging proactive engagement with emerging technologies involves a multifaceted approach encompassing awareness programs, curriculum integration, resource accessibility, industry partnerships, and a supportive cultural framework. By adopting these strategies, educational institutions can ensure they are equipping their stakeholders, not just to navigate, but excel in a technologically enriched educational landscape. References: Burson, J. 2017. The Disruption of Digital Learning. 10 Things We Have Learned. Josh Burson Insights. Available at https://joshburson.com/2017/03/the-digital-learning-10-things-we-have-learned M. and Langworthy, M. 2014. A Rich Seam. How New Pedagogies Find Deep Learning. Pearson. Available at https://www.michaelfalon.ca/wp-content/uploads/2014/01/3897. Rich_seam_web.pdf-iste. International Society for Technology and Education. 2020. ISTE Standards for Students. Available at https://www.iste.org/standards/for-students Kolb, L. 2017. Learning First, Technology Second. The Educator's Guide to Designing Authentic Lessons. St. Puentedura, R.R. 2006. Transformation, Technology and Education. Hippasus. Available at http://hippasus.com/resources/tte/puentedura_tt.pdf.